Hello everyone, welcome to my video on scientific notation. Today we're going to learn how to use scientific notation, how to convert from scientific notation to a number, and how to convert from a number back to scientific notation. Why do we use scientific notation? We use it to, we need a convenient way to express very large numbers or very small numbers. And that's why we use this form here. So notice it's a number a times 10 to the exponent n. Okay. What's really important here to ensure that you have a number that's written in scientific notation is this number a has to be between 1 and 9.99 repeating. Okay, this is to say that usually teachers say it's from 1 to 10, but 10 is wrong. You cannot use 10 because 10, you have 2 digits before the decimal place. Really what you want is to have 1 digit followed by the decimal place. So for instance, if you have the number 2.4, notice that the decimal is between the first digit. Okay, so 2 is the first digit followed by a decimal. That's what you want whenever you have a number written in scientific notation. Okay, because no one wants to write a big number like 24 followed by, I don't know, 100 zeros. That would just take way too long to write. So we use this convenient notation here. Okay. So let's take a look at the example that I wrote over here. We have 4 numbers, 1, 2, 3, 4, and it's your job to determine whether you think these numbers are written in scientific notation or not. I urge you to pause the video and try to figure it out yourself. If we look at the first number over here, we have 24 times 10 to the 6. Is that in scientific notation? For those who said yes, that's incorrect. This is wrong. This is not scientific notation. Okay, why? What's wrong with it? What you have to catch is that the first number here is 24. Is 24 between 1 and 9.999? No. So this is not scientific notation, okay? Let's look at example 2. We have 3 times 10 to the 8. Is this in scientific notation? In this case here, the answer is yes. This is scientific notation. Okay, because you have to remember that every number, we don't write it, but think of 3 as 3.0. There's actually a decimal place right after the 3 that follows the 3. Okay, so even though we don't write it, we know it's there. So here, this number is between 1 and 9.999, so we're happy. Times 10 to the 8, this is perfect, this is scientific notation. Let's look down at example 3. We have 0.11 times 10 to the negative 4. Is this scientific notation? No. If you're thinking no because there's a negative exponent, that's the wrong reasoning. We could have a negative exponent, that's fine. The reason why is, again, 0.11 is not between 1 and 9.99. Look at the decimal. The decimal is before the 1, so this is not in scientific notation. It's smaller than 1, okay? And then lastly, we have 1 times 10 to the 100. Is this in scientific notation? This is fine because the first digit that we have here is 1. That's in between 1 and 9.99. We can include the 1. So times 10 to the 100, this is fine. Yes. 1 times 10 to the 100 is actually the number Google. Google is not just a search engine, it's actually a number. It's spelled Googol. And it would be very inconvenient to write this number, which is 1 times 10 to the 100, which means you have 1 followed by 100 zeros. So instead of writing 100 zeros, we write it quickly using scientific notation. Okay, so let's take a look at an example on how to convert from scientific notation to a number. Here we're converting from scientific notation to a number. It's really important to keep track which way you're going. In this case here, we're starting in scientific notation and we're moving towards a number. So this is a very useful rule. What you have to do is look at the exponent. If the exponent is positive, then we move the decimal towards the right. Okay. If the exponent is negative, then we move the decimal towards the left. Okay, so take a moment, copy this down because this is super useful information. Let's take a look at an example. So in the example I have here, let's consider the number 3.24 times 10 to the 5. Notice first, is this written in scientific notation? Yes, because the decimal falls between the first digit, which is not a 0. And this number here is between 1 and 10, or 1 and 9.999. So we're happy, times 10 to the exponent 5. Okay. So it says, if we read the rule, if the exponent is positive, which in this case 5 is positive, we're moving to the decimal towards the right. Okay, so to convert this is in scientific notation. Let's write that down. To convert it to a number, 3.24, we move the decimal to the right 5 times. Okay, so the decimal is at 3.24, it's right here. Move it to the right 5 times. 1, 2, 3, 4, 5. Place the decimal here in red. Okay, so I moved it over 5 times. 1, 2, 3, 4, 5. And wherever there's an empty hole, you add a 0. 0 and 0. So the number, so from scientific notation, we converted it to the number, which is, let's write this out, 324. Notice the decimal place is no longer there. It moved to the right 5 times. Add your 3 zeros, and we have 324,000. The decimal is here, but we don't write it. Okay, so this is the number. So this is the idea. Let's continue with more examples. In this next example, we have the number 1.1 times 10 to the negative 4. The first thing we notice is that this is in scientific notation because the 1.1 is between 1 and 9.999. And we have now a negative exponent. What do we do in this case? So we've established that this is in scientific notation. But now let's convert this to a number. Since the exponent now is negative, if the exponent is negative, then we move the decimal towards the left now. So the previous example, we had a positive number, a positive exponent, so we move to the right. Now it's negative, so we have to move our decimal towards the left. So let's go ahead and do that. Let's write the number 1.1, and let's move the decimal now 4 times to the left, because the exponent is a 4. 1, 2, 3, 4. Place your decimal, and again, wherever there's an empty space, we put a 0. 0, 0, 0. And even in front of the decimal place. So what we get is 0.12311. This is your number. And this is converting from scientific notation to a number. Let's take a look at more examples. Okay, so let's solve these 5 examples together. If you want, pause the video, try it yourself, and then see if your answers match the answers that I get. So the first example, we have 2.091 times 10 to the positive 6. This is in scientific notation because 2.091 is between 1 and 9.99. That's the first thing you catch. And now we have to convert these here to a number. Since we have a positive exponent, we have to move the decimal 6 times to the right. Okay, so this is equal to 2.091. What I like to do is I first rewrite the number that's here, and then after I move over the decimal. So we're going to move it 6 times to the right. 1, 2, 3, 4, 5, 6, and we're going to place our decimal there. And again, every little hole has a 0 in it. So just to write this number a bit more clear, it's 2,091,000. So 2,091,000. Okay, that's the answer for the first one. We converted it to a number. Let's look at example 2. We have negative 3.82 times 10 to the negative 4. We could have negative numbers, that's fine. That doesn't bother us. But if we look at just the actual number, 3.82, is that between 1 and 9.99? Yes. So we're happy. And here now, notice we have a decimal, we have an exponent which is negative. Since we have a negative exponent, we have to move the decimal to the left 4 times. Okay, so we have, let's rewrite the number, negative 3.82. And we're going to move our decimal to the left now. 1, 2, 3, 4, and we're going to place it here, and we're going to put zeros in the holes. Let me just move the negative. And there's also a 0 in the front. In this case, it's going to be negative. So the number we get is, because the number was negative, it stays negative, and we have 0.1230382. Okay, and this is our answer. Let's look at the next one. We have a positive exponent now, so we're moving to the right. So 5.741. We move the decimal 2 times to the right, so we get 1, 2, it comes over here. So to make this a bit more clear, the number we get is 574.1. We got a decimal here, but that's okay, that's fine. Next example, 8.976 times 10 to the negative 3. Negative exponent, we're moving again to the left. So 8.976, we're moving to the left 3 times. So 1, 2, 3, place our decimal place, and every little hump has a 0 that goes inside. Okay, and since the decimal is to the left, we put another 0 in the front of it. So we get 0, our decimal place, and then followed by 2 zeros, 0, 0, and 8976. 8976. And this is our final answer. Okay. The last one's a bit of a trick. We have 6.71 times 10 to the 0. Well, we said if it was positive, we move to the right, and if the exponent's negative, we move to the left. But in this case, we have 0. What do we do in this case? We don't move. That's the trick. Okay, so if you ever have a 0, you just don't move. The answer is just the number that you have here, 6.71. Another way of thinking of this, which you'll soon learn, is that any number to the exponent 0 is really just 1. So this is a fancy way of saying 6.71 times 1, which stays the same. Okay. So great work. I'll see you in the next clip when we work on converting from numbers now back to scientific notation. Okay, so now we're converting from a number to scientific notation. The rule is slightly different, so make sure you write this down and keep note of the change. The rule says if we move the decimal towards the left, so if we're moving towards the left, then that means the exponent will be positive. Okay, so if we move towards the left, the exponent now is positive. This is slightly different from the rule we saw before. But now keep in mind that we're converting from a number to scientific notation. We're going the opposite way. And secondly, if we move the decimal towards the right, then the exponent is going to be negative. What do I mean by this? Let's take a look at an example. Let's say we have the example, the number 1046, and we want to convert this to scientific notation. How do we do that? Well, the first thing you have to do is identify where the decimal is here. So keep in mind, if you don't already have a decimal with the number that's given, the decimal is always located at the end of the number, not in the front. Okay, so make sure you keep that in mind. If you put a decimal here, the decimal is here, but if you're not sure about that, or if you don't see that, write it down, especially in the beginning. And if you put zeros after the decimal, it actually doesn't change the number. So you could do that as well, but I'm not going to do that here. I just think it's important to keep in mind that the decimal always comes after the number, even though it's not written. And to have it in scientific notation, where do we want the decimal to be? Where do we expect it to be here? Well, keep in mind the number we want has to be, your A has to always be between 1 and 9.99, or 9.9999 repeating. So ideally what we want is to have our decimal place here between the 1 and the 0. Okay. So it is currently here, we want where the red decimal is. That means we have to move 3 times, and since we're starting here, we're moving towards the left. 1, 2, 3. 1, 2, 3. Keep in mind that we move towards the left, so that means this value here in scientific notation is 1.046 times 10 to the exponent. Since we moved the decimal place towards the left, we went to the left, then the exponent is positive, so positive 3. And now we wrote it in scientific notation. Now in this example here, we're given the number 0.01234. This is a number, it's written in decimal form. We want to convert this to scientific notation. We do the same game. Where is the decimal currently located? Here it's actually given to us. It's between the zeros. We have our decimal here. Where do we want the decimal to be? So in order for this to be in scientific notation, we need the decimal to be between the 1 and the 2 to get 1.2. Because now that number is in between 1 and 9.99 repeating. Because if you would have gone after the 2, then that would have given you the value 12, which is too big. Or if you would have gone before the 1, you would have had 0.1, which is smaller than 1, so that's not scientific notation. The only spot that's the decimal has to be is between the 1 and the 2, okay, in order for it to be in scientific notation. So where is our decimal right now? It's right here. We have to move it to the right 2 times. We start here, we go to the right, 1, 2. Okay. Since we move the decimal place towards the right, we know the exponent has to be negative. So we get 1.234 times 10, that's always written there, times 10, to the exponent 2, but we move to the right, so it's negative 2. And this is your answer. So let's take a look at a couple more examples together. Let's continue with these examples here. We're given these following 5 numbers, and we have to convert all of these guys into scientific notation. Okay, so let's start off with the first one. We have 0.000564. So you have to catch where do you want the decimal place to be. Okay. So in order for it to be in scientific notation, remember we want it between 1 and 9.99 repeating. We have to put it between the 5 and the 6 in order to get 5.6. We want our decimal place to be here. So the decimal place is currently here. How do we get to here? Well, we're moving to the right 1, 2, 3, 4, 5 times. Okay. Since we moved to the right and we moved 5 times, we know the exponent is going to be a negative number. So this gives us 5.64 because now we move the decimal place times 10 to the negative 5. Okay. That's done. Let's look at example 2. We have 59,872,000. Okay. Where's the decimal place? It's not here. Keep in mind when the decimal place is not given, it's always at the end. So if you want, you could add it in. So let's place it here. And where do we want to move the decimal for it to be in scientific notation? We need to move it between the 5 and the 9 to get 5.9. Okay. How many times do we have to move? Well, we start here, we're moving to the left 1, 2, 3, 4, 5, 6, 7 times. We did 7 movements towards the left. That means the exponent is going to be a positive answer. So we get 5.9872. Here, if you want to add the zeros, you could, but you don't have to. After the decimal place, when you add zeros, it doesn't change the number. So this doesn't change it, whether you put it or not. So you could just put 5.9872 times 10 to the 7. Okay. If you add the zeros here, it's not wrong. That's fine as well. But it's redundant. Next example 3, we have 90.87. Where do we want to put the decimal place? It's right here. We're moving it between the 9 and the 0 to get 9.0. That's between 1 and 9.99. So we're moving it 1 time to the left. 1. So since we moved it to the left, our exponent is going to be positive. So we get 9.087. Here, notice that the 0 is followed by 8 and 7, so here we do have to write it. You don't have to write the numbers when they finish with zeros after the decimal place. But I think just to be safe, you should write down the zeros, especially in the beginning. So here we converted to 9.087 times 10 to the exponent 1. And now this is scientific notation. Example 4. We have 0.000000014. Where do we want the decimal to be placed? Right between the 1 and the 4 to get 1.4, and now that would be in scientific notation. So we start here, we're moving to the right. How many times? 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So since we moved to the right, our exponent is going to be negative. So we get 1.4 times 10 to the negative 9. And this is a lot easier to write than all these zeros. And the last example, 3.4, this is a trick. It's already in scientific notation. 3.4 is between 1 and 9.99 repeating. So you could just leave it as is, or you could write it as 3.4. Since we didn't move the decimal place, you could write it as 10 times 10 to the exponent 0. And this is scientific notation. Okay. So great work, and I'll see you in the next video.